Which numbers do we want to see on the chart right?
4.
4 and 5. Any others? Gianna, Savannah, any others?
I feel like we should have worked on this though.
That would mean you wouldn't be in school, so we're going to figure out work. For number 4, this is going back to a few units ago, line of estimate stuff. The miles per gallon would depend on the year. So this is your X, this is your Y. Change all of your years to, first one is 0. Every year after that is how many years has it been since. So 20, 40, 60, 80, 100. And in your calculator, you would go into Stat, go into Edit. I have stuff in here, so I'm going to clear it out. If you have stuff in there, you can do exactly what I just did. Go to the top, hit clear, and then come down. And then put your 0, 20, 40, 60, all of those in L1. And then your MPG in L2. And then you're going to go back to Stat, over to Calculate, down to number 4, and then because we're not doing anything else with this, you just need the line of estimate, you could just go straight down to Calculate. And then you needed, I don't remember because I've taught this sometimes, 2 or 3 decimals, so Y equals, if you use 2.24x, plus 16.9, or if you use 2.39x plus 16.905. All right. There we go. Either of those was fine. Questions on that? For number 5, we have to find the x-intercept. So the y-intercept is given already, but to find the x-intercept, put 0 in for y. And solve for x. So get rid of 6 by adding. And then you can either divide both sides by 2/3 or take this, flip it, and multiply on both sides. We have 18 over 2, which is 9. Questions on that one? So last class we talked about direct variation. Inverse is going to go a little bit faster because it's really the same, but with different equations. So let's go on to that. Okay. If you want your direct out, so you can compare, you're more than welcome to take that out. For inverse variation is a specific relationship in which there is a constant product. So this is opposite of the direct. Because direct was ratio. Between all ordered pairs, inverse variation equations are written in the form y equals k over x. So direct was y equals kx, inverse is k over x. Just like what we did with direct to find k, if I was trying to get k by itself here, how would I get rid of x? Multiply. So k k equals x times y or y times x, it doesn't matter. Right? So just like how we found the k value for direct, we're going to do the same thing for inverse. For number 1, we're going to multiply 1 and 20, 2 and 10, and 4 and 5 together. And see if the k value is the same. So 1 times 20 would give us 20. 2 times 10, 20. 4 times 5. Also 20. So that is our k value, because it's the same for all of them. Then to write our equation, it's going to look like this. Y equals k over x. So y equals our k value, 20 over x. Questions on that? Alright, let's do one of the tables. For number 3, again, multiply them. Negative 5 times 2.4, what would that give us? Negative 12. Negative 3 times 4. Negative 2 times 6. And negative 1 times 12. So the k value is the same for all of them. So we would write that y equals negative 12 over x. Questions on how we find our k value so far? Now, this next part, you're not going to have to graph it. We're going to graph this one, but this is just so you see what this looks like. So if we have a constant that is 16, we have to think of numbers that we can multiply together to get 16. What would those numbers be? What will give us 16?
2 times 8.
2 times 8, 4 times 4. There's another. So make it whole numbers. One that everyone misses. 1 and 16. And then we're also going to take these two and flip them. So 16 and 1 and 8 and 2. And we're going to graph all of these points on this graph over here. So these are counted by 2, so the ones you're going to do in between. So 2, 8, 4, 4, 1, 16, 16, 1, and 8. It'll look something like that. Connect all of the points to the best of your ability. Draw arrows at the end. Now, this is half of it. We have to do the other half because all the numbers we said were positive. How else could we get a positive? What two things could we multiply together?
2 negatives.
2 negatives. So take this table and make them negative. Negative 1, negative 16, negative 2, negative 8, negative 4, negative 4, negative 8, negative 2, and negative 16, negative 4. And graph those points. It's going to be kind of the same, but flipped. Connect those points, draw arrows at the end. So this makes a shape called a hyperbola. We're not going to do much with hyperbolas, except you need to know what it looks like. So if you see this graph, that means this is inverse. Okay, we're going to do one problem, and then you guys can grab your phones for lunch. So after you have this, go on to the next page. We're not going to do the two graphs, but you could, during practice, if you so choose. And we're going to use the two equations we just found we're using to find our missing value. So starting at number 7, we need these two equations, y equals k over x, and k equals y times x. So for number 7, just like with our direct, we would find our k value first, take these two numbers, multiply them together. What would that give us?
168.
168. Then take whatever you're missing, set that up in your equation, your y equals k over x. So we don't know what y is, keep that as y. Our k value is 168 divided by x, which is negative 24. What is our y value? Negative 7. Right. And just like before, if I took negative 7 and negative 24, I should get 168. And that's how you would check yourself. Questions on this process? Alright, when we come back from lunch, we'll do a couple more. Alright, let's finish. Did we have any questions about 7 before we do another one similar to it? That is the answer that we're looking for. That's it. So you know we need the answer. Okay. Now you could check yourself if you wanted to multiply these two to see if you get the same thing, but that's not necessary. Okay, so we found y. Let's find x in number 10. So the two numbers we know are going to be in the second ordered pair. So multiply those two together. 21 and negative 3. What would that give us? Negative 63. Thank you. Right, Matt. Then we can set up our equation using the other one. If we are supposed to put it in y equals k over x, we now know our y value is negative 7. K value is negative 63. And we don't know x. So over this x. How would I solve this? Yes, multiply both sides by x. So we have negative 7x equals negative 63. And then divide. So that x equals. What would x equal? 9. Questions on that one? 11 through 14 are just like those, they just have more words. So let's try 11. If y equals 9 when x equals negative 6, find x when y equals 3. So what would our first step be? Think about what we did in the previous two problems. What did we do first?
9 times negative 6.
Yes. Multiply to find k. What would that be? 54. Negative 54. Then we're trying to find x when y is 3, so we have to set up our equation. What would that look like? K 3 equals right, it's going to be just like that last one we just did. Solve for x by multiplying both sides. Focus. Divide both sides by 3. What is x? Questions on that? Yes.
Do I need to pass?
I'm writing it now. Make sure you're back within 5 minutes. Okay, so in this one we found x. Let's do one where we have to find y. 14. Okay, so if y equals -8, when x equals -7, find y when x equals -4. What would we do first?
-8 times -7.
Multiply these two to find k. What is the value for k?
56.
Positive 56.
Why is that down here?
Then set up your equation. Find y when x equals -4. What would that look like?
Y equals 56 over -4.
Damn, Jacob.
What would that be?
-14.
Do you have any questions on that one or any others on this page we want to see you go over before we jump into the applications? Once you're finished writing, go on to the next page. Okay. At the top, mine doesn't have this, but yours does. As one variable goes up, the other variable goes down, or you can write that vice versa. There are many examples, but I can only really think of one. The more you travel, the less gas you have. The less you travel, the more gas you have. So one goes up and the other goes down. If it doesn't say the words about varied inversely, and inversely proportional, if it didn't say that. So just like direct, we're going to be solving it similarly, but using our equation. But first, let's read number 7. Time traveling varies inversely with the average speed. If a train travels between 2 cities in 3 hours at an average speed of 65 miles per hour, how long would it take at an average speed of 78 miles per hour? What is important?
3 hours.
Okay, the 3 hours, time traveling, varies inversely, those words specifically. What else?
65, 78.
65 miles per hour, average speed, 78 miles per hour. So all of those things you can highlight or underline. Just like with direct, whatever comes before the words varies inversely is your y. Whatever comes after is x. So every time you see something related to time, that is y. Something about average speed, that's x. What are we looking for? How long it would take. And is that going to be x or y?
Y.
Y. We're looking for time. Alright, so let's start to set this up just like we did previously. Find our k value by using the two numbers we're given, 3 and 65. Multiply, what would that give us? 195. Then we are looking for y, and we have x and k. How would we set that up? X, which is 78. Divide that.
2.5.
2.5. direct, make sure your answers make sense. Hours can be decimals, so that's fine. The faster we go, the less time it takes. The slower we go, the more time it takes. So that would make sense in this problem, that is less. Questions on that one? Alright, let's do, I'll let you guys choose because all of these are really solving for y. So 8, 9, or 10?
10.
Okay. So for 10, the number of workers varies inversely with the time in days to complete a project. 5 workers can complete a certain project in 24 days. How many workers will be needed to complete the project in 15 days? So what's important?
Number of workers.
The amount of workers, the number of workers, varies inversely with the time it takes to complete the project, time in days. What else? 5 workers, that would be number of 24 days, 15 days, and we're looking for how many workers? Alright, so again, number of workers is y, time is x. So every time you see number of workers, that's y. This would be y. Number of days would be x. What would be our first step?
Multiplying 24 by 5.
Multiply 24 and 5. To get 120. Is that what you said?
Yeah.
Okay. And then how would we set up our equation?
Y equals 120 divided by 15.
Y equals 120 divided by 15. Do that, tell me what you get. 18.
8.
8. 8 what?
Workers.
Workers. Okay. The more workers they have, the less time it takes. The less workers they have, the more time it takes. One goes up, the other goes down. Okay. Questions on how we solve that? Okay. And then let's do 11. The time it takes to bake a turkey varies inversely with the oven temperature. If it takes 3 hours to bake a turkey at 300 degrees, find the constant of variation. What's important there?
300 degrees.
300 degrees. 3 hours. Time it takes. Time is the short. I was trying to do it in the color. And the oven. And what are we looking for? The constant of variation. How would we find that? Similar to what we've already been doing.
3 times 300.
3 times 300. We're looking for K. I'm writing that there. Which is
900.
900. That's it. We don't have to find anything else because it didn't ask us to do that. It just said find the constant of variation, which is K. Do we have any questions on that? Any other questions we want to see on this page or the next couple of pages?
So the constant is K?
The constant is K. It may say constant, constant of variation, constant of proportionality. They all mean the same thing. Any other questions? Okay. So, did you have a question? Okay. For the remainder of class, you could be working on any of these things. practice in the notes. You can go back and practice direct variation from the notes. Work on the Delta Math test due Wednesday on inverse. Work on the Delta Math from Friday on direct. Work on previous Delta Math. Work on making up your tests before you guys want to rate. Retest work. If you choose to be on your phone, you're choosing not to do work. Some of you need to be doing work and not be on your phone.